Chapter 7, what we're dealing with in Chapter 7. Chapter 7 has to do with well, at least 7.1. Let's just focus on 7.1. The goal in 7.1 is for us to get to a point where we can do the same trick that we did in Chapter 5, where we were able to isolate variables by just reversing order of operations. We want to learn that trick for Chapter 6 stuff. And here's the fringe benefit of this. When you're taking the Chapter 6 tests now, there are going to be some problems where you'll be able to use this stuff to get answers more easily than Chapter 6 stuff. So this will actually potentially even help you get some answers on the Chapter 6 test. Okay? So here's what it has to do with. Now in 7.1 we're gonna talk about how we take different kinds of roots than just square roots. You know, cube roots, fourth roots, fifth roots, etc. To be general, we're going to call those nth roots, where n could be anything. Okay? So the way we would write that, if I want to take the nth root of something, take the nth root of a, where a is just some number, I would write it like this, where the n sits on top of the radical stem. Okay, that's what we call an index. The index of the radical tells us what kind of root that we're taking. When we take a square root, there is a 2 there, but we just don't write it. We get lazy because the square root is so common that we don't ever write the 2, but it's there. The index of a square root is a 2. Okay, now we can also write, and this is a much more convenient way to take roots, higher roots on a calculator. We can also write this as a fractional exponent with whatever the index is, the kind of root. So if it's a fifth root, for example, it would be a 5. Whatever that number is can go on the bottom of a fraction with a 1 on top. And we can also write it that way as a fractional exponent. Very convenient way to use a calculator to do higher roots. Okay, so what are the rules of this? There's some rules you got to be aware of, but they're not complicated. But you do have to be very careful with them. We can break it into kind of 3 categories of rules. First of all, if we're taking any kind of root of 0, it doesn't matter if it's odd or even or how big it is, it just doesn't make any difference. The nth root of 0 is always 0. Makes sense, right? Because when you take an nth root of something, all you're really asking is, what number to the nth power is that number inside the radical, right? For example, if we take, think what I just said. If we take the square root of 4, we're just asking what number squared is 4, right? So which would be 2, right? So or 4 we're going to find today, we could also say -2, right? But you know that. If I'm taking the nth root of a number, same kind of a game. What number to the nth power is 0? Well, obviously 0 is always going to give us back an answer of 0. 0 to any fractional power or any power is 0, right? So that's an easy rule. Now we got to look at the other 2 categories of rules here. What about if n is odd? So we'd say now we're taking an odd root of a number, meaning the number that goes on the radical is either a 3 or a 5 or a 7 or an 11 or a 23 or some odd number. If that's the case, one nice thing about this, those are the easiest kinds to deal with because we know that no matter what, we're always going to get exactly one real answer every time. Okay? It also doesn't matter if we're taking odd roots of positive or negative numbers. It makes no difference. It makes a difference, but it doesn't matter. I'm going to get answers for both of those. For example, would you agree that the cube root of 8 is 2? Right? We know that because 2 cubed is 8. 2 times 2 is 4 times 2 is 8, right? The cube root of -8 would be -2, right? Because think about that. -2 to the second power is +4 times -2, so that the third power would be -8, right? And I get back, so now that's okay to do. I can have that negative sign as long as the root is an odd root. It's fine. And I'm just going to get back a negative answer. That's okay. I get no i's in that case, right? So the number can be negative. But we know differently for even roots. If n is even, if n is even, then we know that if a is negative, if a is less than 0, we're not going to get any real answers, right? We know we're going to get i's in there. For example, the square root of -4 is going to give us back plus or minus 2i, right? And in chapter 7, at least in section 7.1, we're only interested in real answers. And so that's good news. You know that I don't even have to worry about those. If I'm taking the 8th root of -10, there's nothing to do because that's an even root of a negative number. And so I already know there are no real answers, and so I don't care. Okay? And most of the time, we only are looking for real answers anyway. And so those we can just forget about. But we got to be careful of that. So the rule is, can't take an even root of a negative number. We've said that a lot of times this year, though, right? You remember going clear back to the start of the year, I've harped on you guys about the 2 rules for real numbers. You can't divide by 0, right? And you can't take an even root of a negative number. At one point, you probably just said square root, but we have to expand that. It's got to be any even root. 4th root, 6th root, 8th root, 100th root. As long as it's an even number, you can't take that of a negative number.
So is the cubic root the opposite of the square root?
It's not the opposite, it's just a different root. A cube root is just a 3rd root. That would just be this case right here, right? That's an odd root, and so what all a cube root is saying is what number cubed is that? Okay? So it's not really an opposite, it's just a different kind of root. Okay, just different index. Instead of 2, the index is 3.
Can the index ever be negative?
No. Good question. The index can't be negative, but we can look at cases where you have a fractional exponent that's negative. It doesn't make sense to write the index as a negative number. Good question. Okay, now what if we're taking an even root of a positive number? Those are the normal kinds you're used to. For example, the square root of 9. Now we know if we do that, we're actually going to get back 2 real answers, right? We're going to get a plus or a minus, right? You're familiar with that. Now where this really becomes important to us is when we're doing stuff like solving equations, right? Like this. And we know we've had a lot of practice with this. Let's go back to chapter 5. How would I solve for x here? Square root both sides, right? And I know in this case, and you're well familiar with this, because that's even, when I solve this, what do I have to include? Say it again. Plus or minus. I've got to have that plus or minus sign in front of my answer. So x equals plus or minus the square root of 9. Well, what's the square root of 9?
3.
So my answers are plus or minus 3. Okay? Now, the same thing holds for something like x to the 4th. If I have an equation like x to the 4th equals 16, a chapter 6 problem, now think how we've had to deal with this in the past. In chapter 6, we've had to subtract 16 and treat this as a difference of squares, right? And that's been ugly. We'd rather not do that. Well, I'm giving you a trick now. You don't have to. Now we can just isolate. You see what I'm getting at there?
Yeah.
This would have been in the past. In your chapter 6 experience, you had to do this. It probably would have looked like this: x squared minus 16 equals 0, and you would have x to the 4th. Sorry, and you would have broken that up. You would have broken that up into x squared minus 4 squared, difference of squares, split it apart, and that's kind of a pain. Now we can skip that in chapter 7. We can just isolate the x, because what was our rule before chapter 6? We always said, and I told you this would always work, and it does. If there's a single x in an equation, you can always isolate it by just reversing order of operations, right? And so we can do that here. What's the only thing I have to do to get the x to the 4th by itself? Yeah, add 16, right? So I get x to the 4th equals 16. Now that's even, sure, but how do I undo a 4th power? How did I undo a squared, a 2nd power? I second rooted it or square rooted it, right? How do I undo a 4th power? No, not square root it twice. I can just do 1 4th root. Okay? 1 4th root. And I can show you a way to remember that too. Think of it this way. A 4th root is also the same thing as a 1/4 power, right? So if I take the 4th root of both sides, if I do the 4th root of x to the 4th equals the fourth root of 16. Now look what that's saying. The fourth root of x to the fourth is just x to the fourth to the 1/4, right? If I take a power to a power, what is the property of exponents for that particular case tell me to do? Multiply. So I get x to the 4 times 1/4, which is what? 1. Yeah, because you get x to the 1. So we don't have to show that work. We just know, like before, if I'm going to do this, if I have an x to the 4th there, I'm going to take a 4th root. But because that's even, what do I have to include? Yeah, I have to include plus or minus the 4th root of 16. Now, what is the 4th root of 16? It's 2, right? 2 squared, so the second power is 4, cubed is 8, to the 4th is 8 times 2 is 16, right? So then this is just equal to x equals plus or minus 2, but I got to get the plus or minus there. Once again, why did I have the plus or minus? Because it was even, because I took an even root of both sides, right? Okay, do I need that? Oops, hang on. Go back. Do I need that for this case? Let's try one more of these. What if I have, whoops. What if I have x cubed minus 8 equals, or plus 8 equals 0? Okay, in chapter 6, I got to break that up into a difference of cubes. That's a pain. But now in chapter 7, there's a single x, so I can isolate it. What do? Subtract 8. Now what? Cube root. Okay. Do I need a plus or minus? No, I don't, because it's odd, right? Because it's odd, I just get one answer. So I get the cube root of -8, which is what? -2. That's my answer. Okay? No big deal. All right, so next step then. Well, we can also have rational exponents or fractional exponents that have numbers in the numerator. So I can have something like a to the m over n, but I want you to think now what that really means. If I have, well, think about the properties of exponents and how they relate to that. We know that I could, if I wanted to, I could break that apart into a to the 1 over n to the m, because our property of exponents that you've already told me is, if I take a power to a power, I multiply the exponents. And isn't 1 over n times m just equal to m over n? Right? What's another name for a to the 1 over n? What did we say about if I have a fractional exponent with a 1 on the top and a number on the bottom? What's another way of writing that? Ah, okay, that's the same thing as the nth root of a, right? To the m. So that's really all this means. If I have a to the m over n power, it's really just the nth root of a to the m. You want to just think of it that way. I'll give you some examples. What if we have something like 9 to the 3/2? That looks complicated, but it's very simple. You always start with the bottom. That's the same thing as saying 9 to the 1/2 cubed. And what's 9 to the 1/2? Well, it's the square root, right? What's the square root of 9? 3 cubed equals 27. See how that works? Okay. How about this? What if I have 8 to the 2/3? Can I do that? I start with the bottom. 8 to the 1/3, right, is just cube root of 8. What's that? 2. So I always start with the bottom. 8 to the 1/3 is 2. Squared is 4. Yeah. Okay, now, I can't remember if this section covers this or not, but now's a good time. What if I do -8 to the 2/3. Can I do that? Is that negative going to cause problems for me? Say it again? No, it's not. You're right. How come? Because I'm cube rooting, right? Because what this really means is the cube root of -8 squared, right? What's the cube root of -8? -2. What's -2 squared? +4. Okay? So because the bottom is the root part of that fractional exponent, that bottom is odd. So it's okay to put a negative number in that. Yes, sir?
How did you get 2 squared up there for 8
Because first we're looking at this part. First we're looking at the 8 to the 1/3 part, which is 2. Right? 8 to the 1/3 is the cube root of 8. All that means is the cube root of 8, which is 2. Okay, and then this 2 up here, we end up with. Okay? Now what about this one? What if I have -9 to the 3/2? Is that okay? No, that's not, is it? Because what that's saying is the square root of -9, cubed. And that's a problem. Right? Because we can't take the square root or any even root of a negative. So that one's not going to work. Right? Okay. How do we do this on a calculator? Is that what I want to show you next? Yeah, it is. Okay, if I want to do this on a calculator, really easy to do. Right? If I want to take what if I want to do this? What if I want to do the 5th root of -87? How do I do that on a calculator? There actually is a way to do this, but it's just not convenient. There's a way to put that in as an nth root, but I don't recommend it. In fact, I had to think about it last period because I don't think I've ever done it except showing you guys. So you can go math menu, and then if you choose number 5, and what you're really supposed to do is put the 5 in first. So actually you're supposed to do this. You're supposed to put whatever root you want, you put that in. So I want a 5th root, and then I go math 5, and it puts the 5 up there. Does that make sense? If you don't do that, you can always go up there and change it in the calculator. And then I would just put in the -87, and it gives me an answer. It gives me a decimal answer, which is useful. There's a much better way to do that, though. Why don't I instead just write that as -87 to what power? 1/5. Okay, now what's wrong with the way I wrote that, though? If I put that in my calculator, watch what happens. If I go -87 to the 1/5, it's actually going to give me the right answer this time. So this is a bad example. It's accidentally going to give me the right answer. Let me okay, instead I got a different one. Oops. Got a different one. Let's do this. I'll make this one red because there's a problem with this one. If I want to do the 4th root of -87, how could I write that as a fractional exponent?
It starts off as wrong.
You're right, it starts off as wrong. I shouldn't get an answer, should I? Right?
Right.
Shouldn't get an answer. But I would write that as -87 to the 1/4, right? Okay, the calculator should tell me, it should blow up. It should say something like non-real answer, right? So let's not literally blow up, but let's see what happens if I go -87 to the 1/2, and I could even put in 0.5 if I want to, that's fine.
1/4.
Oh, whoops, 1/4. I can put in 0.25 if I want to, that's fine. It gives me back, uh-oh, that's wrong. It's supposed to say non-real answer. Okay, but there's a reason. I did something wrong there. Can you tell me what I did? No parentheses. Yes. What the calculator, it's much, much more convenient. So everybody hear this, because this is important. It's much more convenient to use fractional exponents. But when you use fractional exponents, you have to be very careful to always put negative numbers in parentheses. What I did there, what the calculator did for me, was it followed order of operations. It took positive 87 to the 1/4. Okay, I'm looking out, I'm not seeing everybody just riveted to this, which is perplexing to me, because you're going to be taking a test over this very shortly. Okay, so you really want to be, for your own good, you want to be trying to learn this as efficiently as you can. So 87 to the 1/4 is 3.05 blah, 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 and then it multiplied by -1. But if I put in parentheses, negative 87 to the 1/4, now it correctly tells me non-real answer, okay?
What if you were to put parentheses around 1/4?
That's optional. That's optional, but I have to have them around the negative 87, because that's the number that I'm taking to that power, okay? All right, so last issue here. This is what we want to be able to do. Okay. Good luck.
Thank you.
Huh? Good luck. Yeah. Okay. Okay. You go. Softball. Good. Okay. Good luck. So now, what about this guy? So this is an example where, prime example of where now we've got a tool to solve a problem like this much, much more easily than we could have done otherwise, right? Without this tool that I just showed you, we would have to expand out that whole thing, distribute the 2, add 10, subtract 172, and get this big, ugly 4th degree polynomial that I have to solve, which I probably couldn't even do anyway. But now that we know how to use higher roots to solve equations, there's a single x there, so I should be able to isolate it, right? If I just reverse order of operations. So this is the real reason that we learn this stuff. Okay, if I can point to a single x, I can isolate it. Well, what's my first step going to be in isolating x? First step is add 10. Good. So after one step, we've got 2 times the quantity x minus 1 to the 4th equals what? 162. Okay, good. Alex, what's my next move here? So we did this. Say it again. Divide by 2. Yeah, good, good. We're going to divide both sides by 2. Okay, so the 2's cancel, right? And after 2 steps, we've got the quantity x minus 1 to the 4th equals 81. Now, raise your hand. Who wants to attempt the next step? What do I do with the next one? Not square root, 4th root. Aha, okay, good. So step 3, because now we're on exponent, right? So step 3, we're going to get x minus 1 equals. Now, who would care to tell me here exactly what I write? Okay, I can write it as 81 to the 1/4 if I want to. That's fine. Or I can, which however you want to. Or I can write it as the 4th root of 81. But I'm forgetting something. There's something very important that's being forgotten here. Say it again. Well, we haven't gotten to that yet, but there's something in that step that's important that's missing. Plus or minus. How come? Because it's an even root. Because those are even, right? I have to have that plus or minus there, right? And yeah, I kind of wrote over my 4, but there's my 4, right? Okay, so then I can simplify that, can't I? I'm not going to a next step yet. I'm just going to turn that into a number. X minus 1 equals plus or minus, what is the fourth root of 81? 3. Okay. Now, what if that had been a decimal? Well, then it's a decimal. That's fine. Okay. I mean, we can use a calculator for that if it doesn't work out to be a perfect fourth like that. Okay. Now, last step. What do I do? What's the last step? Add 1. And I'm going to add 1 in front of the plus or minus, aren't I? So my last step, fourth step, is x equals 1 plus or minus 3. So what if I take the plus? What's the answer then? X equals 4. What if I take the minus? X equals negative 2. Okay? Make sense? Okay? Yeah. So we can do this stuff.
This is
Okay.
really all this is?
That's all this is. That's all 7.1 is. And that's a lot of what chapter 7 is for, is this. Yeah. Okay, what about this one? This little easier one. Let's say this equals negative 55. Okay, add 1. Now what? Divide by 2. Oops. Okay, now what? Cube root. Okay, so. Do I need a plus or minus? No, I don't, because it's odd. Good. So I get cube root of, uh-oh, is this a problem? Negative 27?
Nope, shouldn't be a problem, nope.
Not a problem, you're right. Not a problem, because it's an odd root. I can take an odd root of a negative. What is the odd root of negative? Okay, good. So x plus 2 equals negative 3, so subtract 2, and x equals negative 5. And we only get one answer, right, because it's an odd root. Okay, make sense?
Yep.
We got it. Good. I'll tell you what, let's go to 209. I think it's open.